Okay, now that we know how to add fractions that are numbers, then it does not change when our fractions now are algebra expressions. And this is important. The rule does not change because we're doing algebra. The song stays the same. Adding fractions easy as can be, all we need is an LCD. We have to make sure the denominators are the same before we ever add our fractions. Once our denominator is the same, then we write the denominator, we add the numerator. That's what collect means. Put together the numerator. Once we get one fraction, then we reduce it by division, and we're done. That are the steps that we're going to follow in algebra, just like we do in arithmetic. So if you look at your PowerPoint, here's our first example. I have 5x plus 12 plus x over 12. So again, I see addition. The first thing I say to myself is adding fractions easy as can be, all you need is an LCD. Yes, I have an LCD of 12. I'm ready to go. So the steps are write the bottom. I write the 12. I collect the top. I'm going to add 5x and x. Now we're back to the beginning of this course. How do you add 5x to x? Well, that's really 5x plus 1x. Those are like terms. That would add to 6x. So now our fraction is 6x over 12. Great. The fraction bar means divide. Can we divide? Sure we can. 6x is a monomial. It is connected by multiplication. So we can go divide. 6 and 12 will divide and make a 2. We'll put the 2 in the denominator because that's where the bigger number is. 6 divided by 6 is 1. 12 divided by 6 is 2. So now we have the expression 1x over 2. And you could write that two ways. You could write it as just x over 2 because we don't need to write the coefficient of 1. But if we write it as x over 2, then it's written as division, a fraction. We can rewrite that as a monomial, which means it can't be connected by division. It has to be connected by multiplication. And we've already discussed this in this course. Dividing by 2 means I'm giving you half of what I have. So instead of writing x divided by 2, you could also write that expression as 1/2 x. And you see how the letter x is in the middle of the fraction bar? Because we discussed that. Anything in the numerator can go down to the middle of the bar. Do not put that x in the denominator, then it will be wrong. All right, let's look at our next example in our notes. X plus 3 over 2 plus 3x minus 1 over 2. All right, we have two fractions. In between them is the operation of addition. So we say, adding fractions easy as can be. All we need is an LCD. Do we have a least common denominator? Sure we do. It's a 2. That's great. So the rule is write the bottom, write the 2. Now we're going to collect the top. Now look in the numerator. In the first numerator you have x plus 3, and you want to add that to the other numerator, 3x minus 1. You have 4 terms in the numerators. Are all 4 terms alike? No way. So here's where we're using everything we've learned in this course. I have x plus 3 plus 3x minus 1. Well, I can add the x to the 3x because they're alike, and that would make 4x. I could add the 3 to the negative 1. Well, really, that's different signs, so I would subtract, and I'd get positive 2. So now my numerator, I have 4x plus 2 over 2. So I put my fractions together, and I have one fraction. But I'm not done yet. I still have that fraction bar, which is division. I need to reduce. Now, everybody look closely at your numerator. 4x plus 2. Is that connected by multiplication? No, it's not. So here's where we start tying in all our concepts. I have a binomial in the numerator. It's not connected by multiplication. I'm going to need to factor it to make multiplication because I cannot do division unless I'm connected by multiplication. So 4x plus 2 has a GCF of 2, so I'm going to take out a 2, and what that's going to leave me with is 2x plus 1. So now in your numerator, you have the GCF 2 times 2x plus 1 over the denominator of 2. And now, because we're written as multiplication, we could divide that 2 for the GCF and that 2 in the denominator will cancel out, and that will leave us our sum, 2x plus 1. Nothing different with adding and subtracting when it's algebra. The rules are the rules, the same as arithmetic. All right, let's try a couple of more on the whiteboard.